We're good? Yeah, here you go.
All right. Thank you all for coming on Friday.
Friday, yeah. We understand that it's this or going home, so we really appreciate you being here instead of going home.
Yeah. And hope you'll be happy that you're here. My name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is I like to bring some of our best technologies to developers all over the world, and also love to get your feedback, and so that we can make our products better. So if you have any questions, please talk to me and or find me on Twitter at Satanism.
Yeah, and he's a very interesting guy. You should follow him on Twitter.
Thank you. And of course, luckily,
yeah, I'm Baruch, developer advocate with JFrog. So by doing what's Ray doing for Google for JFrog as well, and I'm at JBaruch on Twitter.
Okay. And also a very nice person, so you should definitely follow him.
And I wouldn't sure you still think it after today's talk. Yeah, we'll see. Okay. We prepared a little page for you with all the interesting information about this talk, and this animation doesn't work. Here you go. JFrog.com/show notes is the URL. The slides are already there. We will put the video by tomorrow, as Devoxx are very fast with releasing the videos. All the links about all the tools that we are going to mention today are already there. There's a place to leave a feedback and a small raffle, again, to thank you for being here and then coming to this page.
Okay. So what we're going to do today is to show you architecture where you can deploy and manage your microservices. And so we make a little demo application here. Incidentally, this is probably the best looking application I can ever write. It's just black and white. It's bootstrapped.
That's heavy CSS investment here.
Yeah. But look, it's got two of the best applications put together. It's got Hello World and the guestbook. Right? Yeah,
so and you have horizontal line here.
Yeah, that's the top part.
That's the design element.
Yeah. But however, even though it looks very simple, it's actually got microservices behind the scenes, right? So when you click on one of these buttons, it will talk to two microservices behind the scenes, and it's going to say hello back to you, and also store the data. So at high level, this is the architecture. We have the front end as a container. We got two backends here, also containerized, and then we got MySQL and Redis.
So this is like microservices at their best. To write like 3 lines on a screen, you have like 5 microservices.
Yeah.
Good job.
Yeah, thanks. Yeah. So, but hopefully, because we didn't have a lot of time, so it's very simple. But hopefully, we can demonstrate quite a few things about microservices. But we're not going to talk about why you should be doing this, using microservices, but just going to say, if you do use it, here are a few things that you can do. So let's go ahead and take a look.
Let's show the demo.
Yeah. So here I have deployed everything into Kubernetes. I'm running this on Google Cloud in Container Engine. What that means is I just click a button. I got 5 nodes Kubernetes cluster.
Because for such a loaded app, you need at least 5 nodes.
Yeah, this is going to be a very, very popular app in a second. And I have deployed all of these things using Kubernetes by just writing out these declaration files with the YAML file. And I deployed everything in one shot. And once I deployed it, you can clearly see I have like 2 instances of Hello World UI because we need
load balancing.
A high redundancy, right? We have the front end with the load balancer here, and I deploy Zipkin for tracing. I have guestbook service for that talks to MySQL and all that. And then of course here I have the front end UI, and let's just go take a look, okay? And I just need to do is the external load balancer, and that's going to route the request to all the backends that I have here that's running on different servers, and let's take a look.
I think it doesn't work.
No?
Well, that's
no, wait.
In the best of you already got the idea that we do a very modern application here. So we have what? We have white label error page with status 500 and then status 404 and then null as a message.
It's one of the worst error message I've ever seen.
Good news, you have the video backup of this demo, right?
No, I thought you were supposed to have the video.
So, Ray, you have failing demos in each and every talk you do, and you still didn't learn the lesson that you need a backup.
I live on the edge. I never have backup. But you're supposed to have the backup, no? Well, I guess that's it.
Okay, let's go.
All right, sorry everyone. I guess
sorry guys.
No, come back now. Wait. So you're right. I think you're right. I have failed just many demos at Devoxx especially. It's a bad experience. So 2 years ago, I had a demo here, and at 14:01, I think. Yeah, I don't know if you can see it. Yeah, there we go. And I tried to run something. Bad connection. Yeah, no internet.
Error occurred trying to connect.
Yeah.
Nice.
Yeah, just yesterday, I also had a demo here, and also failed at 3100 here. Yeah, somewhere around here. I don't know. It's just, yeah. I was live coding. Let's see it. Hey, that's the same slide.
Yeah, you reuse the slide. That's why your demo is failing.
Yeah. Oh, there we go. Oh. I don't know, man.
You know what? Let's do something different. This time, let's fix it. How about that?
That's okay. Fine. Let's see what we can do to figure what's wrong here.
Yeah.
All right. So
we will be like detectives in a crime investigation in which you are the murderer.
Well, we don't know who that person is yet.
All right, we'll figure it out.
But I know for a fact that since it's returning null, we're running a Java application.
Yes, and it's a null pointer exception. That's a safe bet. This is our hypothesis. When we see null in an error, it means null pointer exception in Java. Okay, so let's see what are you running. It's a Docker stuff on Kubernetes, right?
Yes, it is.
So let's try and see how this image is built and what do we have inside.
Okay.
Which image are you using? What version?
Let's see here. In my deployment file, I can actually see which image I deployed, right? So this is very good tip is that you always need to write a deployment file, a YAML file to capture what you want to deploy. So you can actually go back and see what image that you use, right? So the image I'm using here is this one, the latest one, of course.
Hello World UI latest.
Yeah.
Nice. Which version is it latest?
The latest one. We're doing continuous delivery here. Of course, you deploy the latest all the time.
Is it the latest that you run in staging or the latest you run in production? Are they the same? Do you have staging at all?
I think I do. Let's check, right? So let me see. In Kubernetes, you can actually carve up the cluster into different namespaces. And within each namespace, you can deploy exactly the same application. Even though we didn't have the video, which we should, but at least I have the staging environment, right? So let me see here, get pods, let me see, get servers and see what's in there. We have a staging endpoint. Let's just see if that works, right? And, interesting.
The staging works.
But that one doesn't.
The production doesn't.
Yeah, but I think they're running exactly the same
I think a lot of people have a feeling of deja vu now. The staging works, the production doesn't. Sounds familiar?
Yeah, of course staging works. You wouldn't deploy something into production unless if the staging works first.
Okay, so back to my question about versioning. Is the latest on staging the same latest as you have in production?
Let's take a look. So to do that, what we can do is to do a describe. Not get and describe. We do a describe. The instance that we want to look at. So for example,
the Hello World UI.
Yeah, and we're going to look at it in staging first. And here you can actually see all the different settings that you have for your container. You can also see some of the configurations that you set. But more importantly, of course, it's latest.
Yeah, it's latest here and latest there. Makes sense. Is it the same latest?
Let's see. So for that, you have to check the image ID.
Here we go. Let's compare the image ID.
Yeah, so it's 473E. Yeah. At the end, and let's see what was the staging. Sorry, the production one. So we just say get pause. We see which instance. You remember the last 4 digits already, right?
778.
What?
778.
We'll check. All right. So describe pod, and let's see if the UI has the same image here. And if I scroll up,
778.
778.
Okay.
Dude, that's not the last 4 digit. That's far away from the last 4. Whatever, but you got 3 digits right.
That's the last 3 on the previous line.
All right, fair enough. That's good enough. All right, so that's the same image.
Okay, all right. So now let's see how you build it. You have the registry, right, and it's Artifactory.
Yes, this is in Artifactory,
let's take a look. What do we know about this image?
So we can go to it's your Artifactory, right?
Of course.
So you deploy
every Artifactory in the world is mine.
So it's you. Who broke my view, right?
It's me that provided you with this awesome registry.
Okay, yeah, that's true. So what do you do here?
We can search by checksum. We have a checksum in hand, so we can go and check by checksum.
Okay, let's go take a look.
Here you go. Now we know that this latest is actually build number 50.
Huh.
So we make a progress. Let's go and browse it.
Okay, so let's take a look.
Docker info. Oh,
Hey.
yeah.
Wait, who's that?
Mark G.
You're not Mark.
No, do we have a drum roll and suspense music? Who is Mark G?
No. I don't know, but that's not neither of us.
No. Okay.
All right, fair enough.
Okay.
No.
We'll tell you mysteries and yeah.
Okay, but at least we know.
Docker info.
Yeah,
Let's take a look at Docker info.
Okay.
Okay, so here's your endpoint.
Yeah.
And then your endpoint is running Java, obviously.
Yeah.
We were right about that. Here you go.
Yeah.
And you run a file that is called app.jar. You probably copied it in a previous step, right?
Yeah.
So let's take a look at that. Here we go. We copy a file that is called app.jar, which is again good job in versioning. Any idea what is app.jar?
It's my application. It's every one of these containers has app.jar. So my
Are
guestbook
they
service
the same or different?
app.jar. My other service had they are different, of course.
Very convenient.
Yeah. They have to be different, otherwise this thing wouldn't work in staging, right? Right?
Yes.
Yeah. Okay.
Okay. Let's look again in the 50 and let's try and see.
But can we see? Can we?
Oh, checksum, right? That looks familiar.
Can we do that?
Go ahead and try.
All right. Let me go find. So you taught me about checksum. Let me find. Can we find the
It
checksum
won't
for
work.
this thing? What?
No, it's for the audience. It didn't work.
Why?
Oh, why? Because this is a checksum of a Docker layer, which is a read-only snapshot of the file, not the checksum of the file anyhow.
Oh, I see. So
let's go back to the build and see if we can to the image and see if we can find anything another way.
All right, fair enough.
So we can dive in. You're in guestbook service. You're in the wrong image here.
Oh yeah, you're absolutely right.
Hello World UI 50 is our victim, and if we look at the manifest inside 50,
Why don't you explain that? Yeah.
Here you go.
Oh, interesting.
We can actually find the build tab right here.
Where?
Here. Yeah, all right. So build view is actually how this image was built.
Okay.
So we can inspect it, we can go to the build ID to the 50,
okay,
or we can go to the CI server.
Okay, so
and see information about this. Will take you to Jenkins that actually built it, which have all the info about the build.
Huh. What happened to the CI server?
Well, it's Jenkins. It sometimes goes down and then never recovers.
Never recovers.
Well, yeah.
I don't think this is recovering. We have two failures.
Yeah, okay, guys.
Here.
So, how many of you lost their Jenkins more than once in the last, I don't know, half a year? Yeah.
Oh my goodness, really? Seriously?
Yep. Now, the good news, the bad news are, this is what it is. The good news are, it's not a big deal because we captured all the information about the build of the image inside Artifactory with the image itself.
Okay.
So you can go to the build ID.
Yeah, where? That one?
Mm-hmm.
Okay, so we can go to the build. Dude, Mark
and
is
see more
here.
information. Who built it? Mark built it. Okay.
Mark deployed it, Mark built it. I don't know who that is.
Okay.
Right.
We can see the published modules.
Okay.
And see what's going on here.
Right.
Ah, look at that. This is all your Java for you.
Okay.
Right?
Okay,
Here is all the
cool.
snapshots and then all the Docker images as well. So we captured all the artifacts in Artifactory, and now we can see that. Okay. It's Java, right? So let's see which version of Java did Jenkins used the late Jenkins, the dead Jenkins, used to compile it.
So
in the environment variables.
Did you click into it? Oh,
no, we can just see which Java was in effect in the system variables.
I see.
Here. Let's just try Java. Let's see what happens.
Okay.
Okay, so here you go. This is why. It's Java 8. Of course it won't work.
What? Why?
Because you should use Java 9.
No, I think if you use that, then that wouldn't work. For sure.
Right, nothing works on Java 9. All right, okay. You know what? We can do one more thing. We can compare this build to a previous build.
Oh.
Yep. You go to the diff tab, right here. Okay. And then you select which build you want to compare the build number 50.
Okay.
And see what changed.
Version? Wow. Oh, this is new. I haven't seen this one. Okay.
Okay, so a bunch of artifacts were updated. Obviously, we built new artifacts. Yeah. Dependencies, none of them were changed. All of them are unchanged.
I see. You can see the unchanged column.
Right, and let's see what's going on with the environment variables. Maybe something changed there.
Okay, do I just
keep further down? Yep, here you go. Wow. Well, some of them changed, obviously. The job URL changed, the build number changed. It all makes sense. And that's all. Well, nothing suspicious here.
Can I see? Can I find Mark here?
No. Yeah, no, Mark is not here, so it's not that.
All right,
it's something else.
But how did this information get in here in the first place?
Well, so what we actually do, we used the Jenkins Factor plugin when we built it.
Okay.
And it captured all the information about the build together and then just attached JSON file to the deployed artifacts. You can actually see it here. If you go to the build for Jenkins JSON, this is the same file which has all this information that you saw in UI, and it's open. It's accessible by REST API, so you can process it, and maybe you can find mark there or any other clue on what happened.
Got it.
But I suspect it's not the build. I suspect it's something else.
Okay. Yeah, I agree. I mean, it seems like they're exactly the same image. It works in one environment, but it doesn't work in the other. So I guess we really have to troubleshoot it first.
Let's go and see the logs.
Yeah, that's probably the next thing that we want to do. So in Kubernetes, there's a really easy way to get to the logs. If your application outputs the log to std out, basically standard out or standard arrow, and then we can actually capture the logs and then we can stream it for you. You can actually access it directly with the log commands here. And you don't need to SSH into any machines. You can just give it one of these instance names and we can just see the logs. Now, Baruch, we have two instances here. What are the odds for us to find the log in the right instance?
50%?
50%, all right. What if I do something like that? Now I have 10 instances. What are the odds now?
Still 50%. You either find it or not.
That's very good math there. Yeah, I guess that's true. But let's see if we can have some luck here. So I'm going to do a logs f, right? And I can tell I don't have to SSH into the right machine, but this will just give it to me. Oh, this is bad luck today. I didn't see my arrow. Oh, so
yeah. So you hit
50%.
the wrong 50%. Yeah, you didn't find it.
No lottery today. All right, so let me try the other one, logs f, right? But you see the problem here. If you have a lot, not that one either.
Yep.
What happened here?
Does it work now? No, it still doesn't work.
No, it still doesn't work.
Yeah, okay. Well, log acrobatics are always fun.
Yeah, so I think there are other logs, right? So as you can see, you may not actually be able to find the right logs.
Okay, now we
right
have
place.
10 of them. Good luck.
Yeah, yeah. This is actually a real troublesome thing. I used to do this kind of troubleshooting in production environment for a hotel company, and 12 a.m., 1 a.m. in the morning. Rather than being able to find out the issue, I'm actually spending a lot of time for the very first time trying to copy the logs together, right? SSH and SCP of the logs, they are large and they are separated. You have to divide them up by hours. You got to grab everything. You got to grep them. It was just a very difficult thing to do. In Kubernetes, what you can do, because you output all the logs to std out or std arrow, we can actually aggregate the log for you automatically. You can install Centralized Logger. So if you're using, say, an on-prem installation, you can use something like Elasticsearch and Logstash and Kibana. Then you can tie this whole thing up. Then you can go into your log to search. Now, we are actually running on Google Cloud right now. So what we can do is, because we're using our managed Kubernetes, what that means is we install a Centralized Logger for you automatically. So you have your choice on which Centralized Logger you want to use. But by default, we can give you something here for it's called Stackdriver logging. And what that means is I can just go in and potentially find my cluster here. You may have multiple Kubernetes cluster, and you can also navigate into your namespace. And we just want to see the default namespace, right?
Which is our production.
Which is our production, yeah, running alongside staging, of course. And then we can drill into the application we want to look at. And of course, there will be many log entries. What we can actually do is to just do a search, right? So we can see, hopefully, the type of arrows that we got. So here we got the 404 null, and we can actually see the exception that actually occurs. So
yeah, and surprise, surprise, it's not an null pointer exception.
No, but it's a 404 null at a HTTP client arrow. So I have no idea what that means either. It wasn't very useful.
That's not very useful.
No.
I mean, okay, so we probably should have added more logs.
Yeah, we probably should have done that.
To the source.
Yeah, but before you do that though,
can you correlate? Can you check? Do we have more exceptions on one node than another? Can you do some investigation on the logs? Yeah, so that's one of the things that you may actually want to ask yourself. One of the first things I do when I was in this company, trying to troubleshoot in 2 a.m. in the morning is this error happening everywhere? Or one instance.
Or just one instance, right. because it's 3 a.m. in the morning. If it's everywhere, then I know I cannot go back to sleep. If it's one instance,
Oh, this is easy. Kill this instance and go to sleep.
yeah, you just kill it. No, you can't just do that.
Why?
Well, it's like people who tell me that they reboot their JVM every week because they need.
That's a legit way to stop from out of memory errors. You just reboot it before it explodes, and you're all done.
No, that's a way to cheat. Yeah, you can do that, but no.
But it works.
So you don't get caught up at 3 a.m. in the morning.
There you go.
With you, yeah.
If you restart during the day, you don't need to restart during the night.
I think you have more trouble if you restart during the day. Depends on which time zone you're in, of course. Now, let's find out if this is the issue first. So what we can do is we need to be able to extract more from the log. We need to be able to ask questions. So within this centralized logging tool that we have with Stackdriver, you could potentially send the log instances, log messages, stream them into other things. So you can use messaging with pops up to kind of do a near real-time analysis.
Kind of like a fire hose of events.
Yeah. And you can get like very good alerts here, or you can use storage for long-term storage. But my favorite is actually BigQuery.
Yeah, because we want to ask questions about the logs.
Yeah. So what we can do is we can export the logs to BigQuery, and what that means is, let me close up one of these tabs. I forgot which one. Oh no, not that one. Let me reopen all the tabs again. This is kind of nice. And then let me close. Still not working. All right, fine. So we can go to BigQuery. Where is it? What happened to? There we go. So one of my visualization tool has a really bad memory leak. So it eats up all my resources on my browser.
I just told you how to fix it.
Yeah. Okay. So here we go. And hopefully I'm back online here. And let me go to BigQuery, for example. If I can search it. Yeah. So there's BigQuery. Come on, open up. Oh my goodness, BigQuery. Let me do that instead. I think my browser is dying. All right. So with BigQuery, what happened is that we can export all the logs, if you want, into tables. So these are structured tables. And with all of these fields, we can actually query them.
Yeah, you can run queries now when it's in the table.
Yeah, and this is actually something that we use internally as well. This is based on an internal Google technology called Dremel. We can query terabytes or petabytes of data without any indices. So if you have large amount of logs, you can ask questions like this. So this is, yeah.
So we have two instances. Let's see if the error happens on both of them or only one of them.
Yeah, so what we can do is we can count the occurrences and know which instance is having the issue. We're going to find things with, in container called hello or UI.
And have an exception.
Yep. Group by name and occurrences and limit to 1,000, even though we only have 2.
Yes, that makes sense.
Yeah, so we can run this query. Let me see. Oh, I have the result there, but that's okay.
There we go. All right. Okay. So what we have is one of the instances have 77 exceptions and the others have 4, 2, and 1, which we can discard. It actually Java, so it means like everything's fine. Only 4 exceptions, right?
Yeah, that's okay. So what do we do?
So 77 is our suspect. So now we know on which pod the error occurs, and as I mentioned, we can just kill it.
No, no, Baruch. But because if you kill it, you don't know what happened there. You cannot troubleshoot it more.
Right.
What if it comes back again?
It's like we need to interrogate the prisoner before we shoot him.
I don't want to come on that, but for a convicted person, sure. But yes, well, no. But anyways, we're not killing anything today. I just want to be clear. So what we can do in Kubernetes is, rather than removing this instance, we can actually keep it running, but preventing from serving.
Oh, it's like putting him in solitary confinement.
No, I don't know if that's a good idea, but sure. And then what that means is we can ask this instance more questions.
Interrogate. Yes.
So let's see.
The analogy works. Just promise me we'll shoot him in the end.
Not killing anyone today. So we found this instance that's having issue. And in Kubernetes, what we have is called labels. So every one of these instances has a label. What that means is I can say get pods. I can see the labels app and serving. I added a label called serving. What that means is I only want to, in my load balancer, I when I'm routing these traffic, I route it by the name of the labels. What that means is currently my load balancer only routes traffic to hello world UI with the label that is true. What that also means is I can change this label dynamically, and so I can say rather than doing the rather than having to serve this instance, I can actually just change the serving to false.
Oh,
just like that.
And all this is actually an abstract name. So those are strings. It can be anything, and it just happens by naming convention that your load balancer looking at this particular tag or label to know what is in service and what is not.
Exactly. And now this is in its own solitary confinement. Nobody will be able to get to it except for the people who has access.
And the cameras are off, so we can interrogate him peacefully.
Well, and the way you do it, well, first of all, before I go into this, to see if this is the actual issue, notice that even though I removed one instance from my 10 instances, if you count the number of hello world UI, we have a total of 11, and only one of them is false. The reason for that is because we told Kubernetes that we needed 10 instances, and we removed one of them, and so it automatically restarted another one for you to take over. Which
so
is
that's
nice.
the one with 6 seconds lifespan.
No, that's right. This is brand new.
That's the new one.
Yeah. So with this all isolated, now you can do really interesting things. I mean, you can, if you want, you can go to exec. If you're using Docker, you can do Docker exec in Kubernetes. You can
log in into it.
Yep. So I can do that. And
restart the JVM?
No, we're not restarting anything. but you can do a kill with a 3. I think that will send a signal to do the.
I only know kill -9.
No.
That's the only one I know.
All right, fair enough. But or you can if you have something outputted to the file system, which you shouldn't, but if you did, you can interrogate the file system as well. Oh no, I'm using your terminology now. This is bad. All right. So the other thing is, the other thing you can do is, this is really neat. If you just want to see if this particular instance is having the issue, for example, oh, I took it out of service, but it's still bad. But like if I want to see if this particular instance is bad, what we can do is to do a pull forward. So we can actually do kubectl port forward. I can give it the name of this instance, and then I can say I want to forward from my local port 9090 to the remote port 8080, right? Oh, did I misspell this? Port forward?
Yeah, port forward.
I did.
Here we go.
Yeah. So now I'm establishing a secure tunnel directly from my laptop through the VMs to the right VM to the right container. And so if I go back here and go to my 9090, man, it actually works. And did you forget something? Yeah.
Oh, look at that.
Yeah.
People are
Okay.
writing,
So I guess other people is working for others, right? And this instance is obviously good, but we can also do more things, right? So if you're exposing something on the GMX port, if you want to do some additional management that you not
you saw by the way
outside,
this message. Didn't you forget something from whom it come from?
Devoxx demo.
God.
Yeah.
We didn't made our sacrifices to the Devoxx demo. God.
Yeah.
This is why.
Yeah, that's true. That's true.
Yeah. Now it's too late. Now we'll just have to make it work without the sacrifice. Well, we can kill this spot for the God. Will it work?
We could, wouldn't we? You could do that.
And it would actually fix the demo.
Yeah.
So it all works.
Well, no, but we took it out of the service. It's still not working.
Yeah, it's not a real sacrifice, taking it out of the service. Well, because here you go, you put it back, right?
Yeah, so
you cheated.
So you can decide to kill it by deleting the pod, or you can put it back, right? By putting it back, it's not guaranteed that it will actually be put back. But you can change the label again, and it should be serving again. However, because we told Kubernetes we only want 10 instances, what that means is it will actually go and remove one of the instances.
Which one?
Usually the ones that that's the newest, or the ones that's unhealthy, basically.
Okay, so instead of killing the one that doesn't work, you actually just murdered a 6 seconds old baby. Good job, Ray. Good job.
Instance. These are just applications. But the reason for that is because potentially, the longer running instances are more warmed up. They are more optimized already in memory, and the newer ones are still warming up. And so there's a heuristic you can study on how they chose these.
One of my favorite analogies in the Java world is the infant mortality in garbage collection. This is a very solid one. Yep.
I don't know which talk that is, but I'll have to see it. Yeah. Okay. So I don't know.
We got nowhere. We have not much time left, and the logs got us not nowhere. And I would just wish we had more logs.
Yeah.
But I guess that's kind of
how much
too
time
late.
Do we have? We have like
you have it right there.
Oh, 30, oh yeah. So there are two things that we should have. Well, first of all, I think because it is microservice, right?
Yes.
Something could have gone wrong in between the calls.
Everything could go wrong between the calls. It's microservice.
Yeah.
And Docker.
Yeah. and to actually see what's going on, I think we should actually look at what could actually break in between, right? So in this case,
this is nice.
Yeah. So in this case, I know that they're all talking to each other. Is
it live, this thing? I mean, when you change stuff, does it change?
Yeah, there were 2 and now there are 10.
Oh, this is nice.
Yeah, but you're right though. These lines are not live. These lines are actually documentation.
So you actually draw it in Microsoft Visio?
Yeah. Yes. No. It's actually written in my deployment. So for example, if I go here and I go to my my annotation here, I'm annotating to say who is talking to what. But
is it actually enforcing the connections through the ports?
It is not.
No, it's just for the nice lines in the UI.
Exactly.
Do you have any way to actually see what's going on live?
Yes, actually they are. There are a few tools that you can use, and one of the thing is called Weave, and Weave has a little agent you can install. It's called Weave Scope. And let me see if I have it running. Yeah, so I can run Weave Scope. I can connect use port forward. I can go to my port 4040 locally to see what's running in my cluster. And from here, I can actually see all the live connections.
Those are actually live connections.
Yeah, so you can see these live connections. Because how many times have you ever tried to troubleshoot something with documentation, and then after like 2 hours, somebody tap on your shoulder and say, "Oh, by the way, the
documentation is not up to date."
Yeah, exactly. Yeah. Right. So you just went down the rabbit hole.
Never happens.
Right. So you really need a real-time look to observe and see what's running in your cluster. This is one of the ways for you to see what's running there and what network connections are being opened. But for your microservices, what you really want is with distributed tracing, because you need to see the lifetime of the request and see who actually called what and which service is slower, or in this case, maybe some services failed. And for that, we are actually running Zipkin behind the scenes, and we're using Spring Boot, we're using Spring Cloud Sleuth. So all of the trace information and the headers are automatically created, and it's forwarded to Zipkin. Now, you can run your own Zipkin, and you can see all the traces, or if you don't want to manage your own instance, we have a special Zipkin proxy that can also forward data from Zipkin to a managed service in Google Cloud as well. So let me go back to the console, just show you what that looks like. The idea is the same, it's just different backends, right? So I can go in and I should be able to see traces. So I can go to Stackdriver tooling as well, and we can see a trace. And not only can we see latency, we can actually, some people are trying to DDoS my service here.
Yeah,
many requests here, right? But that's okay. But we can actually...
We're popular. We have class of 10 instances to stand alone.
Yeah, that's right.
We're all good.
Yeah, and you can actually see, like, this is a successful request from William, right? We say hello to William.
Hello, William.
Yeah, and then, the messages went through. And now, if I can find some of these things that has issues, right? Maybe we can find a trace that has issues.
Hey, hello, grid.
Yeah, but easily enough. But you know, maybe we can find the ones that.
Yeah, so we have both 400 and 500. Which one do you want to see?
Let's do 404 first.
All right.
Oh, there is one. Aha.
Aha.
Interesting.
Oh, look at that.
Yeah.
I think.
Oh, there's a 500. I found it.
Yes.
And then they said hello to someone.
And you see the problem? It's right there.
Where?
Do you remember how you had the username in the end of it? Hello, William.
Yeah. Maybe that could be it. And then you can see the 404 here as well.
Yeah.
So, but how can we be sure? I think that's where we probably need more log messages, right?
Right, so this is easy. We know how to find the code because we have the revision of the Git in one of the variables in Artifactory. Yeah. So we go to Git, we find this revision, we check it out, we add more code, then we build it, then we deploy it, then we run it. We hope the error will occur again, and then it will kick in.
We hope the error will occur again.
Can we do it in 15 minutes?
Well, it depends on your environment. If you're in a company which deployment takes 4 or 5 hours or next week to do, that's not going to help, is it?
So all hope is lost. How can we add logs without actually redeploying it?
And also, what if you after you do all that, you find the logs to be unuseful? You need more logs.
Still not good. You repeat?
Yeah. But luckily enough, if we go back to that Artifactory thing, is it still open? No, it's not. In the command line, I don't know if anyone noticed, we don't only say java-jar start, right, with the jar file. We also attached a debugger. And this debugger is actually quite nice. This is actually a debugger from Google that we actually have a similar debugger that we use internally.
We can use it.
Yeah, you want to show Artifactory? You know how to get there?
Yeah, it's right there.
Yeah, it is your. It is your Artifactory after all.
As I mentioned, as every other Artifactory in the world. This
Baruch
one,
pipeline?
yes, and 50 is ours.
That's nice,
yeah, it is easy. And now we have to publish modules. This will be the
But
Hello World UI. Not the snapshot.
I need to see the container setup.
Yeah, we need the Docker stuff.
Yeah.
So
there it is. Yeah.
This guy, and here's our manifest.
Yeah, I want to see the startup command lines.
Yep. We are going here. We're going to the Docker info.
There we go.
Here is your endpoint.
Right. So right here, right here. In addition to just Java jar, right, we actually have attached an agent. And this agent is practically the same agent that Google uses internally for our applications as well. So what this agent can do is to actually allow you to dynamically add log messages to your application. So what that means is if you want to get more logs, let me go and go back to my console. There you go. I can go to debugging. So there is a little thing here called debug, right? And if you have your repository made available to this tool, or if you have a public repo, we can actually go ahead and find it. So here I can find my application, and I should have my source checked in that's accessible. It automatically switches to the right revision that's actually deployed in the containers right now.
So you can actually see the source of what it is deployed.
Yeah, it would find the source with the same revision number. And the way that the revision number is being kept is by using the git.property file. And from here, what we can do is now we can add potentially more log messages. So I'm going to remove one of these, right? And
that's from the previous failing demo.
Yeah, potentially, because I always needed to troubleshoot this, right? And I can zoom in a little bit, and we have here, right, a few lines, and this is how we do troubleshooting for Java developers, right?
No, you just add more logs.
Yeah, you just say one, I'm here.
And this is actually quite sophisticated because you usually send it to this std out.
Yeah.
So if you use login, that's a senior Java developer.
Yeah. Yeah. Or if you're using JavaScript, you kind of need to use std out, right?
No, then you use alert.
Use alert. Yeah. but now we can actually say the name is. We can actually put in the variable for name, so we can actually see what's actually being printed. And then maybe the last one I'm going to put is I'm here. I'm here, of course.
Yeah, no, this is
bad,
classic,
right?
Classic.
Yeah, classic.
Yeah.
As soon as we do this, the log entries will be these instructions will be propagated to all of the 10 instances that we have. And what that means is if I go back here and do a refresh, oh, not that one. I think that's staging, isn't it?
Yes, it is.
That one.
Here you go.
There we go. Right, so that one is still failing, right? So
yes.
Now theoretically, what we should be able to do is to go back to the console, and let's go find the logs. Where are the logs? There we go. Go to logging. Yeah, and then
let's see if it works.
Let's see if it works.
If we manage to add logs without redeploying anything.
Yeah. So we saw the arrow, and check this out. Number one.
Oh,
I'm here.
Here you go. I'm here. Yeah. Nice.
Very good. And number two, the name is Drop Database. Who is this person? Nice try. Yeah, well, happily, that was really good. But now I can actually see this in the log. Who is that person? Drop Database. Nice try.
This is very good.
Nice try. You want to break it for real. But I caught you. That's fine. I bet there's a script alert infinite time as well. But that's not bad. That's not bad.
Yeah,
now
we have it. Now, you know what? That was a fraud detection. Yeah. They actually code an attempt to do an SQL injection.
Yeah, there you go. Another one. So I wonder if I can see all the names is, right? So if I were to do a refresh again.
Name is, name is.
Yeah.
That's what we're
there you go. That came through pretty quickly. I'm here. And the name is Ray. Is
The
that
name
right?
is Ray. Yeah, that's your name.
Not bad, not bad. Yeah, that is me. And we can see all of these things going through,
Yeah,
right?
no, they just won't let us to finding what we look for.
Oh, there you go. Yeah, the one I'm looking for
Is
that one.
this? Yes, the name is empty.
But then you see the problem here. If there are so many log messages, it doesn't really help you either. So what you need to do potentially is not just output what you're looking for, but you can also restrict the conditions. So if I want to add a new log message, this is really nice. I can actually add a condition here, right? So with the condition, what that means is if you know the request ID that you want to send through, if you know your session ID that's in scope, you can add the condition here. So you can narrow down the logs that you're going to produce.
And ignore all the SQL injections.
Yeah, exactly. That's right. But sometimes logging is just not enough either, right? I mean,
you know what? Yeah, logging is kind of lame, right? We just saw how hard it is. I wish we could debug this thing.
Like attach a real,
attach a debugger, like an IntelliJ. Yeah.
No, but that will stop the world.
So they will wait.
They will wait until me or you step through every commands that we want to see.
That's a nice job security. It will take us all day.
I guess just two of us. And whenever something's not responding, like we get to keep our jobs.
Here you go. We see and click through all the breakpoints.
Yeah, I suppose. Yeah, I can do this continuously, but we can do better. With the same debugger, we can also attach what we call a snapshot point. So these are points where we don't stop the world, but we can actually see what's going on. So for example, if I want to see my hello world service here, and I know the code is probably going through here, I can attach a snapshot. Now, anybody, including the person who tries to drop the database right now, try to drop it again, I will see this flowing through, and we should be able to see a response, right? So for example, if I do a refresh, right, again, it goes through one of the instances. I come back, it says that we have called the code stack, right?
Here you go.
And now I can clearly see
that the name is empty.
The name is empty.
Nice.
So this is user error.
Yes, that's the user error. Someone didn't enter a name, which is, valid. You handle all exceptions well. You check that the name is not empty and everything. Yeah. Good job. Good job. But you have five microservices and 10 instances. So
yeah. And I think I'm also the person who started this demo, wasn't it? So
so as I said,
I'm gonna cost this.
You are. It's not Mark.
Yeah. So all of this is my fault. All right. So hopefully you actually see the different tools that you can use to identify the issues.
So first of all, let's just fix it. Open up a new browser window.
Yeah, let's do that. So I'm gonna go to guestbook. Now I'm really scared to see what everybody put into this.
Yeah, we will see now everything. Yeah, that will be a lot of fun.
Oh
Here
my God.
Go. We are popular.
I knew that was the case.
Here you go. I told you the alert is coming.
Who's pretending to be me? Is there another Ray in this thing?
Two of them. Look.
Two of them.
And they actually have the same message in mind.
Yes.
Oh, this is good. This is good, guys.
Thank
you for participating.
Yeah, thanks. This is always fun. I don't know what the question marks are, but I know I don't deal with UTF-8 characters.
Let me guess, this is Russian.
Potentially. Yeah.
I know my Russian. Yeah. I see it. I recognize it when I see it.
All right. So we've been through a lot. We got 7 minutes left, right? So let's just do a quick recap, right?
Yep.
So we saw all the tools and things that you can do. You can use labels to play around with how you want to load balance. You can use, the thing for potentially taking instances out. You need to have a centralized logger to help you to understand what's happening. Hopefully, you can actually query it. But more importantly, you do need some kind of distributed tracing so you can identify the real issues behind your microservices calls, right? In case some of the service is slow. In case that the service is actually slow, what we can actually do is because we record the latency that you give to the service, we can actually build a report. We can give you, the 99th percentile or 80th percentile of the latency distribution. But we can do actually even better. Because we have data from the past and current, what we can do is we can compare the latency distributions between your versions. So, for example, if you deploy the new version this week, you can compare the latency between the previous week. So you can actually identify performance regressions if you want to. And we can generate this report automatically for you.
I have one question for you, Ray.
Yep.
So we saw this debugger, which is very nice.
Yep.
But I'm not a big fan of those IDE in the cloud. I would prefer to use the IDE that I know and familiar with, like IntelliJ. Is there any way to attach this magic non-stop the world debugger actually from IntelliJ?
Actually, that's a great question. Since we have time, we should show it. So yes, you actually can. So if I can find my demo. I don't know what that is, to be honest. Guestbook demo? Hey, tell you what, this is what I'm going to do. Yes, you can. If I can find my demo, I can open this up in my IntelliJ, just like JFrog Kubernetes, right? I can open, oh, not that one. Where did it go? Example Java. There we go. I can open my
Here we go.
Yeah. Yep. So I can actually open existing project. I can actually have my debugger IDE plugin inside of IntelliJ.
No, this is amazing.
Right? And you don't actually have to upload the source code. You can just troubleshoot it directly from IntelliJ like that.
And this I like more because most of the people won't have their code publicly on GitHub, and I'm not sure how many of us want to upload it to Google with everything, and that's fine.
Yeah. So you can actually attach it to your local debugger. You can find the version. And what this is going to do is also check out the revision that you're supposed to be debugging. And again...
here we go. New snapshot received.
Yeah, there you go.
Let's take a look.
Yeah, who is still using my app?
Everybody.
Everybody. Somebody is still trying to hit it with the name with an
empty name.
Yeah,
no, it won't work. We checked.
Yeah.
No, empty name won't work, guys.
Yeah. So there you go. It's right there in your ID.
Now we're talking. This is awesome.
Exactly. Okay. So with all that said, let's go back to where are the slides again? There we go. Yeah, so remember, if you want to be able to really identify your issues, I mean, it was hard enough with just one monolith application across multiple servers. It was really hard with so on. With microservices, you just really need the right tooling to be able to observe and also get insight into your cluster. You need to be able to trace, to have log and debug. And potentially there are tools out there you can use. And so
all the Stackdriver tools are amazing. Don't forget we have all the logs, all the notes, and all the links in jfrog.com/show notes. Both Stackdriver and all the rest that we showed today. Yeah. So this is it.
Thank you very much for being here on the last day. Yeah, thank you.
And we have 3 minutes for questions.
Yeah. Any questions? There's one over there. I see.
Yeah.
Yeah. Go ahead.
We have.
Yeah. Right. So the question was with the IntelliJ here, how do we authenticate with the debugger stack, right? So each of the application instance runs the debugger agent. And that agent will need to have credential to connect to a central server, which is us. You can actually run this debugger in any environment. This debugger is not limited to Google Cloud, right? So if you run the debugger agent on your local host, you just need to give it the right credential, and it's going to be able to connect to the central server. Once it's connected from IntelliJ, you install the plugin that also authenticates you to the same project. And from that same project, when you click on debug, right, you can see what projects I can debug, and I can also see the applications that have privileges to debug.
And your username was right there in the list of the project.
Yeah, sure. Exactly. Yeah. Right, so this is mediated through a central server. Yeah. Question? Yeah, go ahead. Can you have conditions on the snapshots? Yes, you can actually. So there you go. So once you set this snapshot, you can also give it the Boolean condition here. So you can have an expression.
It supports everything that the cloud version supports.
Yeah. Now, it's actually quite dangerous sometimes if you put an expression to say, I don't know, like request that generate ID or something, or if you call like new ID, right? You could inadvertently introduce new variabilities into your code by doing this, right? That is why this debugger is very smart. If the things you're trying to call will modify the state, it will actually not execute. So this will prevent you from accidentally changing the state of your running environment. This is really, really cool. Yeah.
Yeah, no, I remember I used a lot of hacks by changing stuff while running in the debugger, so that's a bummer.
With what language? With the,
Java.
Java.
Yeah. You use a condition and then you change it, and then all you need to do is keep the debugger plugged in without any breakpoints, and it changes the behavior of application in production. This is how we used to do it all the time.
Interesting. Yeah. Sure. And then you kill it afterwards. Yeah.
Because it actually wasn't so great.
Okay.
Yes.
Fair enough. Okay. 30 seconds. Any other questions?
Yeah, here you go.
Yeah.
Oh, the overhead question.
Yeah, this is a typical question I get.
We always get it.
Yeah. So very minimal, like single digit, like 1% or something like that. It's very, very minimal for the amount of things you get. It is so minimal that we actually run this in production environment within Google as well.
So when Google is slow, that's why.
No, when Google is slow, it's somebody like Baruch trying to debug something with a real debugger and stepping through the code.
No, jokes aside, it's really worth it. It's the stuff that you can do in 3M in production is definitely worthwhile. This 1% of overhead.
Yeah.
Okay,
well,
I think we're all set. Yeah. Yep. Thank you very much, guys.
Thank you. Thanks, man.
Good job.